So this is the core idea, that what is the increasing or decreasing and how we will do the question. So see the first. Okay, everything is fine, good network. Okay, so see the main idea, the positive derivative mean what? If f dash x is greater than 0, it means function is increasing, or if your derivative is less than 0, it means function is a decreasing. Very simple. Why this is true? The derivative of dash x represent the slope of the tangent. Now any one question come in your mind, sir, why f dash x greater than 0, then function is increasing? So that's the reason. The derivative f dash x represent the slope of the function. We know that very well. Dy by dx is equal to what? Slope. And slope what represent actually? Inclinations. So if your derivative is positive, then function is increasing, going upward. But if your derivative is decreasing, then your function going downward. So if f dash greater than 0, function is increasing, or if f dash x less than 0, function is decreasing. So if the slope is positive, the function is going uphill as you move to the right side. If the slope is negative, the function is going downhill as you move to the right side. So that's why if the derivative is greater than 0, derivative is greater than 0, function is increasing, or if derivative less than 0, function is decreasing. You got it this? Why derivative greater than 0, so function is increasing?
Yeah.
Suppose you have any function. Let us suppose you have any function. F of x is equal to suppose x square. So what is the derivative of this?
2x.
2x. Can I say this is positive greater than 0?
Yeah.
So this is a increasing function. Yeah. Suppose I have another function. F of x is equal to x cube. Now tell me, this is increasing or decreasing?
3x squared.
So 3x square,
Increasing.
which is greater than a 0. So this is a
0.
increasing function. Now let us suppose you have negative this one. Now what kind of this function? So the derivative of this function is a 3, then minus x square, and the derivative of this is negative 1. So this is negative x square, which is less than 0. So this function is a decreasing function.
Decreasing.
Yes. So you got the meaning of increasing or decreasing?
Yeah.
Good. Now we have some critical function point in the graph where the graph changes the behavior. And how we will find this? By putting derivative equal to 0. So after doing the derivative, you have to find the critical point. You need this picture in the group? Let me share.
No.
No need. So how you will revise later?
Okay, then you can put it.
Now see how we will find. Not taking screenshot. What happened? Okay. Now see what is the critical point. So for a function's behavior increasing or decreasing, to change, the slope of its tangent line must change sign from positive to negative or vice versa. This can happen at a specific point, and that point is called a critical point. It means critical point are those points where the function changing from increasing to decreasing or decreasing to increasing. and we have to find that point. And after that, we will check what is the left of that point or what is the right of that point. So critical point is x is equal to c of a function f is a number where derivative becomes 0, or f dash c is a undefined, does not exist. There are only points where a function change from increasing to decreasing or decreasing to, it means you can say that at that place, you can say that critical point at those point where in left side or right side function change its behavior, that we have to find. Suppose, let us suppose you have a function, any function, suppose x plus 1 whole square. So first method is find the derivative of this. So what is the derivative of this? 2x plus 1, right or wrong? Right?
Yes.
Now put,
Yeah.
to find critical point, put f dash equal to 0. If f dash 0, then this becomes 0. 2 cannot be 0. So it means x plus 1 equal to 0. Or if x plus 1 equal to 0, this implies x is equal to
X equals
negative. So this is the critical point. This is a critical
decrease.
point where our function change its behavior. And suppose you have a function fx is equal to x square. So what is the derivative of this function? 2x.
2x.
And when we put f dash x equal to 0, this implies 2x 0. 2 cannot be 0 because 2 is a constant number. So it means x 0. So this x is called a critical point of this x square. And we know that graph of x square is like this. Right or wrong? So you can see x0 is called critical point, and in left side of 0 or in right side of 0, the function behavior is different. Right or wrong?
Yeah.
In right side function is increasing, but in left side function is decreasing. So you got it? So that's why you can say that this point is a minimum point, or minima you can also say that. There is no maxima because in both direction function going upward. But in left side function is decreasing and in right side function is increasing. So you can say that from minus infinity to 0 function is decreasing, and from 0 to positive infinity function is increasing. You got it?
Yeah.
So if you have a function, first of all find the derivative of the function and then find the critical point of the function and check the behavior of the function at the given left side or right side of the point. So you got it?
Yeah. So do you plug in the critical point back into the derivative?
Yes. So first find a critical point. And then plug the value. Now let me discuss one example. We have to start from 23, right?
Yeah.
What is 23 number question? Fx is equal to x minus 1 whole square into x plus 3, right?
Yeah.
Okay. Let's see. This is our function. And what we have to find? Find the critical point, find the open interval on which the function increasing or decreasing, apply the first derivative test to identify the relative extrema, use the graphical utility to confirm. Okay, so it means we have to find the critical point first of all, and after that we have to find the interval for which function is increasing or decreasing. Okay,
Mhm.
So what is the method to find the critical point? Do the derivative.
Derivative.
Yes, do the derivative. First derivative you can say.
You expand the function first and then do the derivative.
Yeah, you can use both method. You can also apply the product rule. And I think I prefer the product rule because product rule helped me to factorize or to find the critical point easy. Because if you expand this after the first derivative, you have to again factorize the polynomial. But if you keep the same factor and apply the product rule, so after the first derivative, no need to make the factors. Factor is already present, you have to take common only. Now what I'm saying, my mean is that apply the product rule direct. No need to expand. So d over dx, x minus 1 whole square, and then x plus 3. Consider this is your first function, this is your second function in product. Considering first and second doesn't matter. You can change, you can take in any order. So first same derivative of second, which is equal to 1, plus second same to the derivative of first, which is a 2x minus 1. You have any problem in this?
No.
So after this, what you have? You have this. Now you can see, no need to make factorize. You can take direct common x minus 1. X minus 1 is common in both. So x minus 1 is left, and then 2x plus 6 is left inside. Right or wrong? So this is x minus 1, or this is 3x, or this is positive 5. Right or wrong?
Wait,
Now if
why is x minus 1 alone?
huh?
Why is x minus 1 alone? Because wasn't x minus 1
This is
squared?
not
What happened?
alone. I took common from this and from here or from
Oh.
here. Yeah, that's why I not advise you to open this. I will explain why, what happened if I open, and what our work is increase if we open and then apply the derivative. Now you can see, if I want to find critical point CP, I have to put a f dash x is equal to 0. So by setting this, I have x minus 1 or 3x plus 5 equal to 0. This give me x is equal to 1 or x is equal to negative 5 by 3. So these two are my critical point.
Wait, I have a question.
Yes.
So isn't there 3x minus 1s? Because if you take out 1x minus 1, then there's x minus 1 plus
Yeah.
2x.
Actually,
6.
I skip one step here. Actually, square mean x minus 1 or x minus 1. I thought you understand this, how to take common, but let me explain one line more. Actually, this we have. Now
Yeah.
you can see x minus 1 or x minus 1 common in both. That's why I took common. After taking common this, you have left this in first term. And after taking this common, you have
Yeah.
2x plus 3 common. And now after this, I apply this 2 inside. So 2 into x plus 2 into 3, 6. You got it?
Mhm.
Yeah. But I thought you understood how to take common, then I took directly. Like that, x square, or if you have x, then minimum x is common. So after taking common x, we have this. So you got it?
Yeah, I got it.
Okay. It means your 8th grade, not 8th grade, 9th grade is very weak, right? You not learned properly.
No,
Because
it's just we don't have time to go in depth, so they go really
the
fast.
problem is time and practice. I
Yeah.
know you study very well, but the problem is time.
Mhm.
Rizek is learning these kind of things in polynomials, quadratic function, and I think he is in 8th grade, right? Yeah. So it
Yeah.
means these are the part of 8th grade. Now you can see these are the two critical points. Now the point is, sir, what happened if I expand this, and what is the difference? So see, if you want to try expand, so first of all you have to apply the identity x square plus 1 minus 2ab, right or wrong?
Yeah.
and then you have to multiply this with this. So x cube plus 3x square, 1 with this x plus 3, and now 2 with this minus 2x square, and then this minus 6x. Right or wrong?
Yeah.
Now you have to combine the term. So x cube is only single term, 3x square minus 2x square become only 1x square, and you can see x or 6x minus 5x and then plus 3. This is your expanded form of the function. Got it? Now we are interested to find the derivative of this. So f dash x is equal to 3x square plus 2x minus 5. Right or wrong?
Yeah.
And this is a quadratic equation. And now if you want to find out critical point CP, you have to factorize it. Now you tell me, this method is easy or this method is easy?
The product is easy.
Product is easy. That's why I told you, without expand, apply direct derivative. Now you understand my point, why I'm telling this method number 1?
Yeah.
Because method number 1 will give you critical point easily. Because you can see, now you have to make factor, but in this format, no need to make factor. You have already factors present. You have to only put equal to 0. But this expand form increasing my step. See, this step is extra, this step is extra, and then again if I have to make factorization, then again this step is extra. So this is increase my workload, but this is very easy method. So now you have a critical point, and you have to identify the behavior of function in left side or right side of the critical point. Give me 1 minute. I'm going to share this picture in the group. Okay, so our half work is done. Now tell me what we will do in next, if you have any idea. Otherwise I will tell you. You have two critical points, x is equal to 1 or x is equal to minus 5 by 3. So x is equal to 1 or x is equal to minus 5 by 3. Now tell me how we will identify what is the behavior of function in this side or this side, and what is the behavior after x is equal to 1. How we will check?
You have to plug it into the derivative to see if you get positive or negative number. But you don't plug in the number. You have to
You want to plug a critical point in the.
No. Hello.
Wait a second. This is 23 number question, right? Okay. So what do you want to put inside the function? Critical point or something else? Sir, we put the point near the critical point. Right or wrong?
Yeah.
So this is our critical point. And if you want to check the behavior in left side, choose any point here. Tell me any point. Any point left side of this.
-2.
How you can choose -2? Yeah, you can choose because this is less than -2. So you can choose the -2. So after putting -2 here, what we have? This is -3 or this is a positive 1, right or wrong? But -2 not give you correct answer. Why? Because if you put -2, this is positive. But if you put -5, this will be negative. So negative 2 not giving you the exact answer. So put a largest number than this.
Where do you plug it in? You plug it into the original equation?
Yes, because the graph of this line is given by this function, not the derivative.
Oh.
Yes. So choose the point near to the critical point, which is little bit large. So you can suppose -4. If you put -4, this is negative. So in this side, the function is a negative.
Wait, -5 squared plus times -2.
So I can say
Yes.
that if I put -4, the function is negative, right? But after that, in the left side, suppose x is equal to 0. If I put, then this give me positive value. So you can see from negative function start increasing. So can I say negative to positive, it means function is decreasing and now function is increasing. So minus infinity to -5/3, my function is a
Increasing.
how something is else. Something is else. Give me one moment. We are forgetting something here. Oh, we have to check the sign of f dash x actually, not the function. Okay, this is the like this is a wavy curve method that we will use in another second derivative test. But in this format, if we want to find out the increasing or decreasing, so we have to check derivative, not the function, because it's not giving the exact value. So if you want to choose any point near this, suppose x is equal to, you choose a -2. So put this in f dash. What is our f dash? Put here x minus 3 or 3x plus.
So you plug it into the f prime?
Yes. So
Oh.
what if we put -2 here? We have -5, and then this is also negative, right?
Yeah, so it's positive.
Positive. So if it means function giving positive value. So in this interval, function is a increase.
Positive.
Yeah.
Increasing.
Okay. And after this, you can choose any value. Suppose x 0. If we put x 0, then this 0, so -3, and then 5. So we have negative answer. If answer is negative, it means from
Decreasing.
-3 to negative infinity, function is a sorry, not negative infinity, till 1. Function is a decreasing. Okay. After x is equal to 1, you can choose any point, for example 2. So if we put 2 here, so we have -1 or positive. So answer again negative. So function from 1 to positive infinity, function again decreasing. Function again decreasing.
Decreasing.
So actually, after finding the critical point, we have to put the value. Give me 1 minute. There is some problem, I think. If we put more than 3, see, we have x is equal to 1. If we put x is equal to 2, then answer is negative. But what happened if we put x is equal to 8? Then in entire case, answer is positive. You can see this is positive, this is positive. So function is not decreasing, actually function is increasing. So increasing, decreasing, increasing. You got it? Now the problem is that, sir, how I can identify?
Wait, how is it increasing?
Because suppose after x is equal to 1 you have 8, right or wrong x? Why we not choose x is equal to 8? Or if you choose x is equal to 8, then this is 8 minus 3, positive 5. And then 8, this is also positive, 29. So the entire answer is positive. And if the derivative is positive, function is increasing. But the
So why can't you put 2?
yeah, why we were decreasing?
How do you know?
Because we immediately take the point of after the x is equal to 1. So maybe this function is wait a second. Oh, my bad, my bad. I took wrong derivative. This is 1, not 3. You
What?
can see. We took wrong data. That's why the problem is happening. You got it?
What?
We took wrong derivative here. Actual derivative is this, x minus 1. I wrote 3 here. That's why the question is going wrong. And then 3x plus 5. Okay? Now if you choose x2, this is positive or this is also positive. So positive mean increasing. If we choose any 0, then this is negative or this is positive. So function is decreasing. I did mistake because I took wrong derivative. I took here x minus 3. That's why my answer is going wrong. Actual derivative is x minus 1, not x minus 3. Okay?
Okay.
So actually what are the steps? Can you define me? What we have to do to find the increasing or decreasing? Sir, first of all, find the derivative, right or wrong?
Yes.
And then sir, put derivative equal to 0 to find the critical point, right or wrong?
Yeah.
So critical point, split the line into 2 and 3 part. And sir, if you want to find out the increasing or decreasing, took the point near the critical point and then put into the derivative to find the increasing or a decreasing. Now it's time for 24 number question. Now tell me, I will write here, you can guide me what I have to do. Okay, this is the function. First of all, I want to find out derivative. So if I want to find out derivative, so I will direct apply d over dx here. So x plus 2 whole square and x minus 1. Now you can see this is first function and this is second function. So I am going to keep the first function same. Derivative of second is 1. Then plus first remains same, derivative of second which is 2 times x plus 1. I hope you got this. And now you have x plus 2 whole square plus 2 times x
X
minus
plus 1?
huh?
X plus 1 or x minus 1?
Oh, no, wait. This is x plus 2, not 1. Because this is the derivative of this first function. Got it?
Okay.
Okay. So now you can see x plus 2 or x plus 2 is common in first term and second term. So you can take common. So after taking x plus 2 common, here only one x plus 2 is left. And this go outside, so only 2x minus 1 left. Now open the bracket inside the bracket. So x plus 2 and this is 2x minus 2 f dash x. Now after solving one more step, I have this. This is 3x and this become cancel. Now if I want to find CP mean critical point, put f dash x equal to 0. If derivative 0, this implies x plus 2 or x equal to 0. 3 cannot be 0 because 3 is a number. So either x plus 2 0 or x 0. So if this 0, x is minus 2 or a 0. So these two are my critical point. It means these two critical points split my number line into some interval. So this is x minus 2 or this x is equal to 0. So this critical point line critical points, split the number line into three intervals. One is minus infinity to minus 2, another minus infinity minus 2 to 0, and 0 to infinity. Now what is my derivative? My derivative is, this time I will write carefully, 3x then x plus 2. Okay, this is my derivative. Now if you want to find out the increasing or decreasing, choose any point less than minus 2. I can say that minus 3. Let us suppose x minus 3. If x minus 3, this is negative and this is also negative. And negative negative become positive. So here the derivative is positive. That's why function is increasing. You got it?
Yes.
Now choose any number between minus 2 to 0. So let us suppose x is equal to minus 1. When we plug minus 1, this part become negative or this part positive. So function is negative. So it means in this interval, my function is decreasing. And now choose any point greater than 0. So let us suppose 2. So if we put 2, so this is positive and this is also positive. And positive positive give us positive. So it means function is increasing. So from minus infinity to 0 increasing, 2 to 0 decreasing, and from 0 to positive infinity function is increasing. Are you getting my point?
Yes.
Everything is clear?
Yeah, I understand.
Okay, very good. (23 to 33). Okay. 23 to 33. 23 to 33. Now do one question. You. Let's do this question. 26 number. I will guide you. So first of all, find the derivative of this. So what is the derivative of 26?
4x cubed minus 32.
Okay. And now set this derivative equal to 0.
X equals 2.
X is equal to 2. You are right. It means this will divide your number line into two interval. Can you tell me that two interval?
Negative infinity to 2 and 2 to infinity.
Absolutely right. Now tell me the left side of that 2. What is the behavior of function?
So I plugged in negative 2.
You can choose any number, suppose 1. So put the 1 into the derivative. You can also choose 0.
Negative.
Negative. It means function is decreasing in the left side. Now choose any point greater than 2. Check the sign
Positive.
of f dash. So positive. So you can say from 2 to positive infinity function is increasing. Right. Okay. So you understood?
Yeah.
Good. Very good. Now do the one more question, that is from modulus function. 32. This is a mod function. How you will do the derivative of this? Huh? Because the derivative of mod function, we have not any formula. So you have to make the piecewise function of this modulus. So you need help or you want to try?
You need help.
You need help?
Yeah.
This is not good because I already explained you how to convert this into piecewise function. So the piecewise function of this is positive. When you put 0, you have x is equal to -3. So this is positive if and only if x greater than or equal to -3, or this would be negative if your x less than -3. You are getting my point?
Yeah.
But the function is not only this. Function is -1. You have to subtract -1 from this. So -1, -1, and -1 here. So actually our given function, which is x plus 3 minus 1, f of x is this one, x plus 3 minus 1 if x greater than equal to -3, or minus x minus 3 minus 1 if x less than -3. And after solving one more step, I have x plus 2, my function, if x greater than -3, or minus x minus 4 if my x less than -3. Do you have any doubt in this function? So it means my given function is convert. And now finally what I have, x plus 2 if x greater than -3, or minus x minus 4 if x less than -3. So you got it?
Yeah.
Okay. Now do the derivative of this.
One plus two, and wait. It will just be one and -1.
Yeah. So if I want to do the derivative of this, my derivative is 1 if x greater than -3, or -1 if x less than -3. It means this function is very easy as compared to other. I have interval x is equal to -3. For less than, I have -1, or for greater than, I have +1. So value is -1, it means function decrease. For positive value mean function increasing. So -3 to infinity, function is increasing, included 3. Or from -infinity to -3, function is decreasing. You got it?
Yeah.
Are you sure?
Yeah, got it.
Okay. Do one more question. 31 number question. Same question. You can take the reference of this 32 and do this 31 number question. Everything in front of you. So compare and do the same thing. Try your best. So first of all, make a piecewise function, okay?
So because it's negative in front, is it x plus 5 and x minus 5.
First of all, tell me the point where function is changing. How I find the function or find the x in the last question where I wrote x greater than minus 3. How I get that x minus 3? X is equal to minus 3. How I get?
Because you made x plus 3 equal to 0.
By setting inside part of mod equal to 0. So if you set inside part of equal to 0, you will
Equals
get
5. X equals 5.
Right. So x greater than equal to 5, this bracket will be positive, or x less than 5, this bracket will be negative. And then solve it. You got it?
Yeah.
Send me photo. Are you sending?
Yeah.
send it? Let me check. Why you not consider 5? Where is 5? Huh?
Yeah.
Why you forgot to put 5 here? Actual
So what about
function is 5 minus something. So you have to count 5 also. Why are you ignoring 5?
where do I put the 5?
See, this 5.
Yeah, where do I put
Why are
it?
you ignoring? Right here 5. Like this. And also 5
Oh.
here. But this time this bracket is negative. So the outside this become like this. 5 minus this bracket is positive when you put in greater. Everything is correct, but you miss something here. Minus
Okay.
5. And for the second one, 5 minus, right now this bracket is negative. So negative become positive x minus 5. You got it?
Mm-hmm.
Condition is correct, no problem. Derivative is correct.
Why is the x minus 5?
Hmm?
Why
So
is the x minus 5?
x minus 5. Which x minus 5?
5 plus
This.
x minus 5, 5 minus x minus 5.
Yeah, this is not correct. You forgot 5 to put 5. So if you open the bracket, you have 10 minus x, first function. See,
Because
listen.
when you do the derivative, it's 5. X plus x equals 5.
See, Arshia, condition is correct. Condition is correct, no problem. But this function that you make is not correct. The problem is that I'm not talking about any derivative. You make this function which is not correct. The actual
Mm-hmm.
function is this. For this condition, the bracket will be positive. So 5, 5 minus keep minus, but this is positive. So that's why I'm putting only x minus 5. But in the second case, when x less than 5, this bracket will be negative. So this negative become positive. So this is positive x minus 5. The first function is 10 minus x, or the second function is only x. Now if you do the derivative, this will give you negative 1 or this will give you positive 1. Negative 1 mean decreasing or positive 1 mean increasing. So for greater than your function is decreasing, for less than your function is increasing, because you are getting positive for this. So at x is equal to 5, in left side you are getting positive, so increasing, and in right side negative, so decreasing. You understand?
So how do you plug it in? Can you show that?
Why you want to plug? Huh? You have direct value of derivative. No need to plug anything. This value is wrong. Actual value is this. Let me explain again. After solving the entire things, you have this fx is equal to 10 minus x if your x greater than equal to 5, or x
How is it
equal
10 minus
to x
6?
less than 5. Right or wrong?
How is it 10 minus 6?
10 minus x is, we are getting after solving this, 5
Is it
minus x
plus?
minus 5, not plus. You have
Oh.
negative 5s. You can see. You change this sign, but this is the wrong. You can't change this sign. You have to change the sign of entire bracket. One time this or one time this. You cannot change the function of inside the bracket. But see, actually the property of mod is this: x positive or minus x. Positive when x greater than equal to 0, or negative if x less than equal to 0. But if the function is not like this, if your function x plus a, then this bracket entire will be positive. If when we put this equal to 0, we get x minus a. So if x greater than or equal to minus a, or this entire function is negative if x less than minus a. You are getting my point?
Mm-hmm.
Or if this function is like this x minus a, then again same thing. This entire bracket is positive if, when we put this equal to 0, we have x is equal to a. So if x greater than or equal to a, or this entire function inside the mode is negative if x less than, getting my point?
Yeah.
Are you sure?
Yeah.
So let us discuss one more example of same kind. I have a function f of x minus 4 plus 20. So first of all, tell me the piecewise function of this. Make the piecewise function of this. Tell me what I have to write. Tell me. I will write here. I am waiting. What I have to write here? The positive?
Yeah.
Tell me the condition. If x greater than equal to what?
4.
4. Set this equal
Yeah.
to 0. So we will get 4. So it means x greater than or equal to 4. Or tell me this is negative if and if x less
Less
than.
than 4.
You are getting my point?
Yeah.
But you can see the function is not only this, function has also 20.
Plus 20.
Yeah. So add 20 on both sides. Now this is the final function. So add 20 here. Like this, or also 20 here. Getting my point?
Yeah.
Yeah. And now if you understood this, do one more question of same kind. This time you have f of x is equal to 7 minus x plus 3. Now tell me, first of all, make the piecewise function for this. Make the piecewise function of this. Tell me, this entire function is positive. Tell me the condition.
Plus x plus 3 if x is greater than or equal to 3.
Not 3. When you're setting this is equal to
Oh,
0, you have negative 3.
Yeah.
Please pay attention. Greater than minus 3. And this entire function is negative if x less than minus 3, right?
Yeah.
But the real function is not this. Real function, first
Then
of all,
minus.
you have to apply negative and then add 7. So when we apply negative, this positive become negative or negative become a positive. And now add 7. So add 7 here like this. So the new function that we have given become this 7 minus x plus 3 if x greater than minus 3, or 7 plus x plus 3 if x less than minus 3. Got it?
Yeah.
And now you can simplify this. So this is 7 minus 3 become 4 minus x, or this become 10 plus x. And when we will do the derivative of this, you can see this give us negative 1 or this give us positive 1. So it means this is x minus 3. So greater than x minus 3, negative 1 mean decreasing, or less than x minus 3, positive mean increasing. So you can say minus infinity to 3 function increasing, or minus 3 to positive infinity function is a decreasing. You understand, Arsia?
Yeah.
So today we discuss entire topic, that is increasing, decreasing, interval and critical point by the first derivative test. And I hope you understand everything very clear. Your homework is all the question related to this concept. Okay. Okay.
Okay.
That's all about today's class. Bye bye. Take care.
Thank you.
Homework I am giving same as school. Okay. Bye bye. Take care.